Hi, this is Dr. N. Sreelekha, Professor in Physics, Siddhartha Institute of Science and Technology, Puttur. Today I am going to explain about simple cubic crystal structures. So before going to know about the simple cubic crystal structures, first we should know the importance of crystal structures. So in present scenario, in all sectors like in digital watches, sonars and computer chips, at everywhere we are using crystals. So here, what are the learning objectives of the present concept? So by successful learning of this concept, students can able to obtain the knowledge on arrangement of atoms in a crystal and also understand the number of atoms in a crystal. And finally, students can analyze the internal structure of the crystal also and learning outcomes of this present concept. After successful learning of this concept, students will able to recognize the atomic arrangement in a crystal, means how the atoms are arranged in a crystals, and also distinguish the types of the crystals also. We have different types of crystals. We can easily learn the types of the crystals. The contents included in this concept are crystal structure, number of atoms in simple cubic crystal, coordination number, nearest neighbor distance, atomic packing fraction, and finally void space. So before going to know about the crystal structure, first we should know what is meant by lattice. So here I was shown the lattice and basis structure. So see, so this is the lattice. So lattice means periodic arrangement of, lattice means imaginary points. So imaginary points means we are going to imagine the atoms are existing in this way. That means in a symmetric manner. This is like a periodic manner. So atoms are arranged in a symmetric manner or periodic manner. These are imaginary points. So this is called as this type of arrangement of atoms is called as lattice. And this is the basis. Basis means here already we know the lattice points are exist in a periodic manner, which are shown by the black dots, and two atoms are attached to this every lattice point here. For example, so basis means the group of atoms are attached to the every lattice point is called as basis. So see here, this is one atom and this is the second atom. So this is an example only. So here two atoms are attached to the every lattice points, either 3, 4 or and so on. So the group of atoms are attached to the every lattice point is called as basis. And the combination of lattice and basis is called as crystal structure. So this is the formation of the crystal structure. And next one. So in simple cubic crystal, we should know first of all number of atoms present in a simple cubic crystal. So here number of atoms means the total number of atoms are present in a simple cubic crystal is here only one atom. One atom only present in a simple cubic crystal. So we should know the how that one atom is present in a simple cubic crystal. So here I was shown the diagram of simple cubic crystal and body-centered cubic crystal and face-centered cubic crystal. So see, in a simple cubic crystal structure, this is the simple cubic crystal. Actually, cubic means it has 6 faces. So 6 faces and it has 8 corners. So in simple cubic crystal, every corner we have one atom is present. So see, this is one atom and this is the second atom and this is the third atom. Like that, here we have 8 corner atoms. But every corner atom is shared by the neighboring 8 unit cells, adjacent unit cells. So every corner atom is shared by the 8 adjacent unit cells. So, but the contribution of this atom to this unit cell is 1 by 8 only. The contribution of this atom to this unit cell is 1 by 8 only. 1 by 8 only. So like that, every corner atom contribution to this unit cell is 1 by 8 only. So we have 8 corner atoms. So 8 into 1 by 8. 8 into 1 by 8 is equal to what we get? 1 only. So the total number of atoms, complete atoms present in a simple cubic crystal is only 1. Only 1. So, like this, we know the number of atoms present in the simple cubic crystal. That is only 1 atom is present in the simple cubic crystal. And next. Next, coordination number of simple cubic crystal. Coordination number means the total number of nearest surrounding atoms present in a simple cubic crystal. So, coordination number is 6 in a simple cubic crystal. So, see here in this diagram, we have considered this atom. So, the number of nearest atoms surrounding this atom is 6. 1, 2, 3, 4, 5, 6, like that. So, the number of very closer atoms to the considered atom is called as coordination number. So in simple cubic, only 6 atoms are very closer to the considered atom. So 6 is the coordination number of for simple cubic crystal. And next, nearest neighbor distance. So nearest neighbor distance of simple cubic crystal is the distance between the two nearest neighbor atoms. So see here, let us consider two atoms. So these two atoms are very closer to each other. So the distance between the middle of the two atoms is 2r, that is equal to A. So this is the nearest neighbor distance of simple cubic crystal. 2r is equal to A. Nearest neighbor distance is A, that is equal to 2r. So next. In simple cubic crystal, what is the atomic packing fraction? So atomic packing fraction means the volume occupied by the space or volume occupied by the atoms in a crystal, that is in a simple cubic crystal, which should be divided by the volume of the unit cell. So in the simple cubic crystal, the number of atoms are present, that is one atom. So the volume of that one atom is divided by the volume of total unit cell is called as atomic packing fraction of the simple cubic crystal, and that is defined like this. So we are going to derive the atomic packing fraction of the simple cubic crystal like this. So see here, in a simple cubic lattice, the nearest neighbor distance A is equal to 2r. Atomic packing fraction is equal to, the formula for that is volume of atoms in a unit cell by volume of unit cell. So number of atoms in SC, simple cubic crystal is only 1. Volume of cubic crystal is 4 by 3 pi r cube. Volume of unit cell is actually A cube. Here A is equal to 2r. So then finally 2r cube. So atomic packing fraction is by dividing both, we get 5 by 6. So we get atomic packing fraction is 56%. So 56% of the space is occupied by the atoms in a simple cubic crystal, and remaining 44% of the space is void space. That is the empty space. Void space means empty space present in the crystal. So atomic packing fraction of the simple cubic crystal is 56% and void space of the simple cubic crystal is 44%. So this is totally about simple cubic crystal in crystal structure. Next, thank you.